In this video, we'll be looking at how to find the derivative of cos x using the first principle. And by first principle, we'll be using the definition of derivative. In order to use the first principle to find the derivative of cos x, there are two things that must be noted. The first is the limit of sine theta over theta as theta tends to 0, and that is equal to 1. The second thing to be noted is the trig identity of cos A minus cos B, and this is equal to minus 2 sine A plus B over 2, then multiplied by sine A minus B over 2. So given the function of x to be equal to cos x, and by definition of derivative, f prime of x, which is the derivative of our function, is equal to the limit as h tends to 0 of f of x plus h minus f of x, then all over h. Now, if f of x is cos x, that means f of x plus h is equal to cos x plus h. So f prime of x is going to give us limit as h tends to 0. F of x plus h is the same as cos x plus h, minus f of x is the same as cos x, then all over h. If we compare this with this trig identity, here we have cos A minus cos B, and here we have cos x plus h minus cos x. That means A is equal to x plus h, whereas B is equal to x. In that case, A plus B over 2, A plus B over 2 is going to give us x plus h plus x all over 2, and that is equal to 2x plus h over 2. Also, A minus B over 2 is going to be equal to x plus h minus x all over 2, which is going to be equal to h over 2. That means f prime of x is going to give us limit as h tends to 0. Cos x plus h minus cos x is going to result into negative 2 sine A plus B over 2 is the same as 2x plus h over 2 multiplied by sine A minus B over 2 is the same as h over 2 all over h. Therefore, f prime of x is going to be the limit as h tends to 0. So, negative 2 sine 2x plus h over 2 will also be the same as x plus h over 2, then multiply by sine h over 2 all over h. Dividing both the numerator and the denominator by 2, we are going to have limit as h tends to 0, negative sine x plus h over 2 multiplied by sine h over 2, then all over h over 2, which is equal to limit h tends to 0, negative sine x plus h over 2 multiplied by sine h over 2 all over h over 2. From here, we said that limit as theta tends to 0 of sine theta over theta is equal to 1. As theta tends to 0, sine theta over theta is equal to 1. That means as h tends to 0 here, sine h over 2 divided by h over 2 is also going to be 1. In that case, f prime of x is equal to, so as h is tending to 0, this one is going to be removed. Then we are left with negative sine x plus, this is going to be 0 as h is tending to 0, then multiply by, so this one is going to become 1. Therefore, f prime of x is equal to negative sine x multiplied by 1. Therefore, the f prime of x is equal to negative sine x. So from our deduction, if f of x is equal to cos x, that means f prime of x is equal to negative sine x.